fastener. Join me now to find out how on How Do They Do It? The miracle of modern global communications. With just one click of my index finger, I can order a box of fair trade organic vegetables from Scandinavia, some much needed light blue pills from a girl called Veronica, or a first-class degree in media studies from the University of Milwaukee. Our fantastic wired world is linked together by cable. Just think about it, if I gave this a hard enough tug, Veronica would fall off her chair. But how do they lay enough stuff to link up the entire world? Just how do they do it? The French port of Calais. In a quiet corner of the docks, this ship, the Ile de Seine, is taking on board an intriguing cargo. Is it a rope? Is it a garden hose? Whatever it is, it hasn't been packed in a container like most cargo these days, but is being fed gradually from the quayside onto the ship. This loading never seems to end. It's very long because it's got to stretch all the way to another continent, and it's treated with care because this garden hose is in fact an extremely delicate bit of high-tech equipment. It's a massive length of undersea fibre optic cable, and the Ile de Seine is taking on board an extraordinary 5,000 kilometres of the stuff. Making fibre optic cable is a fiddly business, requiring the delicacy of touch and eye for detail of a top Harley Street surgeon and some really clever machines. This miraculous stuff is optic fibre, a tiny hollow filament of glass finer than a human hair. Along it, it's possible to send data. Electrical signals from your computer or telephone are converted into pulses of laser light and then channeled along the fibre at the astonishing rate of 300 million metres every second. By weaving multiple strands of this fibre together, every undersea cable can carry over 1,000 gigabits of data every second, enough to keep millions of people merrily blabbering away on the phone or surfing the internet. But of course, the ocean floor is a pretty inhospitable environment, subject to strong currents, hungry fish and corrosive seawater. So the fibre optic cable needs some heavy-duty protection. This stuff looks like ribbon, but if you wrapped a birthday present with it, you'd be unlikely ever to find out what was inside, because this ribbon is made from high-grade steel. To stop it getting tangled, it's fed through a complex series of pulleys in a contraption 15 metres wide. It's like a vast high-tech spinning wheel. The strands of fibre optic are carefully brought together and the steel ribbon is folded around them. Metal rollers squeeze the steel tight and a tiny weld then seals the join. After wrapping with a waterproof plastic coating, the undersea cable is good to go. Now, if you've got an electric lawnmower, you'll know what it's like. The electric cord behaves like a deranged python. No sooner do you unravel the damn thing than it decides to wrap itself around your arms, legs and neck. Now imagine you're trying to mow a lawn in America, but the nearest plug socket is in France. You see the problem? Simply getting all the cable onto the ship is enormously tricky. Rattling on at 100 metres a minute, they need to constantly monitor its progress because the last thing they want is to wind up with kinky, twisted or knotted cable. The cable is fed below deck to two massive tanks, 7 metres deep and 19 metres across. Together, they take around 5,000 kilometres of cable, or enough to stretch from London to New York. The team works fast and in shifts. They have to take turns to eat and visit the loo, because once they've started, they don't stop. This strange dance carries on uninterrupted night and day for 3 long weeks. The effect is mesmerizing. If you're not used to it, even a few minutes in the hold, let alone several hours, is enough to make you feel disorientated and slightly weird. Back up on deck, the crew is busy loading aboard a series of torpedo-like objects. These are special amplifiers, and they're essential to making the cable do its stuff. Just like a long-distance runner, the further the signal travels, the weaker it becomes. So after every 50 kilometers, they will fit one of these amplifiers. And like a double espresso, it will boost the signal back up to its original strength. The coordination is extraordinary. They've even developed their own complex hand signals.
Like a telepathic transfer of information, they just basically sign language or a nod of the head and wave of the hand here and there.
The Ile-de-Seine has been custom built for the job of laying cables across the ocean floor. Dynamic positioning propellers allow her to follow a very exact course while she slowly releases the cable at about 1 kilometre an hour.
How I describe my job to people at home, the analogy I use is if you're in a plane flying over the Alps, say it's 6,000 metres above them, and we have this string, this cable out the back of the plane, and we have to fill the contours of the Alps as we progress across the sea, you know, say from UK to America.
It will be another 2 weeks before all the cable is aboard. But then the Ile-de-Seine will spend a staggering 7 months crossing the ocean, slowly offloading its precious cargo as it goes.